Hello and welcome to this video about matrix proofs. In this video we'll prove this theorem, that two matrices are row equivalent if and only if they are row equivalent to the same matrix in reduced row echelon form. The if that's written with two F's isn't a typo or a spelling mistake. It means if and only if, and can also be written as a double arrow. So now to start this proof, we'll define two matrices to be row equivalent to each other and call them A and B. We're going to work in the forwards direction first, given by this arrow. And we'll use this squiggly line or tilde to stand for row equivalence. And by a past theorem, they're row equivalent to their reduced row echelon forms. And because the tilde is an equivalence relation, we can say that these two matrices are row equivalent immediately, using transitivity and symmetry. We work this out in the middle of a past theorem, that if two matrices aren't equal to each other, then they aren't row equivalent either. It might be helpful to have a look at this. It's because Gaussian row operations won't do anything to a matrix that's already in reduced row echelon form, and therefore there are no row operations that can transform a matrix that's already in this form into another matrix that's also in this form. And then we can get the contrapositive of this to say that these matrices must be equal. And then I'll just write this equality down. That's half of what we're trying to prove. We've proven this in the forwards direction. So now to prove this in the reverse direction, we'll define A and B to be two matrices that are row equivalent to the same matrix in reduced row echelon form. So that's way too much information. We only need to say that they're row equivalent to the same matrix, and we'll call this matrix R, standing for reduced row echelon form. And then we'll use the fact that it's an equivalence relation to say that A is row equivalent to B. We mainly use transitivity and a bit of symmetry to swap one of these statements around. We can treat it like an equal sign and get new statements immediately. So that's it, we've proven this theorem. So I hope that you found this video to be helpful and educational. Please click like and subscribe if you did. Feel free to write anything helpful in the comments and to share this video. And thanks a lot for watching.